So in this design, I've maximised the input voltage to 600 volts at the power connector of our demo PCB. The first thing we need to do is define the voltage. So you're just seeing I've defined the voltage in the constraints browser. This is used in combination with the design rules to create appropriate spacing to avoid creepage issues. So in this demonstration, we'll be focusing on the 600 volt signal, okay? So the next thing we need to do is go into the rule editor. There is now a new voltage difference tab. Here is where we define the creepage rules. So I've defined here 3 clearance tables: external coated, external uncoated, and internal. These rules are based on IPC standards, which provides a formula for adequate clearances regarding creepage. So you can use the formula or enter a defined value. This is therefore a clearance which varies with voltage difference, but can also vary within a range of thresholds, making this a sophisticated solution for creepage rules. The voltage rules can also be defined as RMS or peak values. So you can see there we've got some thresholds there. I've used the formula in the rules and then assign them to the conductor layers. So from the report tab, we can now invoke the creepage checker. You can set a search distance. So here I've used 5 millimeters around what is selected for the creepage check. Then eCADSTAR will check in X, Y, and Z, and even around the edges of the PCB. Once you've selected a signal, net or the entire board, a results dialog will appear where you can filter by caution and fail results. So we're just focusing on this 600 volt error here. So you can see from the results that the creepage issues exist. So creepage distance on the same external layers for the 600 volt signal. So all we need to do is double click cross probe and you'll see this error line. So this error line is very helpful as it's guidance where we need to rectify the creepage failure. So we can have a little look in 3D mode as well, and then you will see that error line there on layers 1 and layers 8 as well. So I love the interactive trackball, so you'll probably see me messing around with it quite a lot. There are a couple of other errors on this design on the pin next to it, but we're just going to focus on pin 3 there. So we're going to take the traditional approach of inserting a slot in between the signals using eCADSTAR's slot command. And then we're going to invoke the creepage check again to see if we still have failures or if they have been resolved. Okay, so you can do a select window, or you can select a particular net, or you can select the entire board. So let's say, okay, so that's done. We've still got failures there that we need to resolve, some violations. But you can see that the error path there, the creepage path, has now changed. So you can see that change there on layers 8, layers 1. Always nice to have a little look in 3D mode, see how that board's going to be built. Okay. So in this case, we probably need to make that slot a little bit longer. Again, just demonstrating the cross-probing capabilities there, and that's on layer 1. Okay, so to make this slot longer, we invoke the Properties tab, and we can just click on that slot in 2D mode, and then we can just increase the length there. Okay, now we can invoke another creepage check to see. Okay, so we have significantly less errors there on that 600 volt line. So those errors have been resolved. So if we just go into the pass section, we can now have a look at the creepage path there. So you can see it also, eCADSTAR also shows you the creepage path from conductor, the top conductor to the bottom conductor there. So generally when you put a slot in, you've created a new path there. So you can see now that those violations have been resolved.